Welcome to Garden Views, interesting conversations with interesting people who have done and or are doing interesting things. So sit back and enjoy. Welcome into Garden Views. This week, our guest is Matt Williams. I know it's not the power hitter from the San Francisco Giants and the Arizona Diamondbacks, but wouldn't that be fun? Now, this Matt Williams, he is a space journalist and space author. And let's quickly say hello. Hi, Matt. Thanks for coming into Garden Views.
Well, thank you. Thank you for the invite.
Sure. Why don't you tell the folks a little bit about yourself, your background, and what you're doing now?
Well, like you said, I'm the space journalist and science communicator is the technical term that I often find myself using there. Mainly because my peers do, and it pretty much says it all. I write for a bunch of publications like Universe Today and Interesting Engineering. I am starting a podcast series on IITSB Magazine's channel, and other than that, I've been doing this for several years and have had the chance to meet some very interesting people and groups. And so I'm very, very interested in sharing stories from my experiences or talking about developments in space, because that's pretty much what I do all day long.
Well, that's great. And I stumbled upon Matt probably in one of those areas. I follow a gentleman named Fraser Cain, not Fraser Crane, but Fraser Cain, who co-hosts a show called The Astronomy Cast with Pamela Gay. And that show, it's in its 600th of episodes, probably 620. So, obviously it stood the test of time. And in our conversations, it turns out not only does he follow them, but he has a working relationship with aforesaid Cain and Gay, but also with Professor Avi Loeb, who has never been on my show, but the publicist was kind enough to send me a copy of the book. And if you go back probably about a year and a half, I did a show called Book Report, one of my 2 or 3 solo shows, which was never my favorite thing to do, where I discussed Avi Loeb's Extraterrestrial, ironically also with Chariots of the Gods with Eric von Daniken. So probably 2 people coming at things from a very different perspective. But Avi Loeb, for those who don't know, is an astrophysicist. He's the head of a department at Harvard. If folks remember, a few years back, there was a piece of space debris which was agreed upon to be interstellar. So it originated from outside of our solar system. It was called Oumuamua. I might be pronouncing that incorrectly, which translates to Scout, because that's the observatory that found it in Hawaii. And while most of the scientific community seems to have settled on that it was just a piece of space debris, an asteroid or whatever, Professor Loeb went out on a limb and said, no, based on the shape and the trajectory and how it changed speeds and motions and directions, he doesn't believe that it's possible, that it's something natural. He didn't, a lot of people, said it was a space invader or whatever. I think he says it's more like space debris, but basically it was too long and too flat and spherical, the way that it changed direction, that there was no gassing, and the way light reflected on it. He did not believe it was something that we've encountered, at least as of yet, in nature. Anyway, not to take too much on that, but it's interesting because now Oumuamua is, again, extra solar system, and so it's probably too late for us to find it. But he launched something called the Galileo Project, or him and others launched it, and now they are looking for similar objects, as well as his other duties. And I only mention that because this is someone that Mr. Williams indicated that you were part of his research, or became associated with it, or familiar with it. So I'll let you tell the story better than me.
Oh, okay. Well, thank you. Yeah. Well, so yeah, I know Professor Loeb, and we talked on many occasions, and I've reviewed his book and a lot of his research. I haven't contributed. I'm sad to say, but they would be best not to get me involved in their research there. I technically not a physicist, so I wouldn't really be of much help. But yeah, our association actually goes back to about 2014, about the time I started writing for Fraser Kane in Universe Today. And at the time, he was deep into talking about hypervelocity stars, and which are stars that periodically get kicked out of galaxies, um, either due to interactions with a black hole, or they get spun up by a companion that sets them off. And he wrote how yeah, these stars can carry their planets along with them. So we talked, and I was hugely inspired because I thought that's science fiction gold right there, but also a really interesting study, because and I've seen lots of subsequent papers, and just the other day, in fact, I saw one that said that this could be how life is being distributed throughout the cosmos. Not just on a one solar system to another from asteroids, but entire galaxies could be populated life uh, by stars being flung out with their planets. Um, and yeah, so over the years we had a chance to speak quite a bit about any new research he had coming out, because he's very prolific. He was the chair of astronomy at Harvard. He founded their Black Hole Initiative and um, their advanced computation group, and so they do all the heavy theoretical physics stuff and the black hole stuff, and so there was always interesting research coming out. And then yes, 2017 was when Oumuamua flew by. Oh yes, I was going to say, you were very close in your pronunciation there. It's Oumuamua, right? That's yeah. It's all about where you stress, what syllables you stress there. And yeah, it was about a year later. Well, obviously that was a very interesting occurrence, because that was the first interstellar object we've ever detected, and it triggered a huge slew of research, not the least of which was from him and his associates there at Harvard Smithsonian Center for Astrophysics at Harvard itself, and yeah, they were running a lot of simulations on how common these objects would be, and then there was some interesting findings from other researchers who were doing related stuff, and they said that yeah, there would have been countless interstellar objects entering our solar system over in the course of its history, and several thousand of them would have stayed and been captured. And they were even pointing out which objects are likely to be captured objects, and that we could go study in the coming years. And then Professor Lowe did his, because of his work with Starshot, he'd been deep into talking about light sailcraft and, tiny spacecraft with giant sails that could be used for interstellar exploration. And so, yeah, that's how it sort of came together. He got to thinking, well, now let's look at all the information about Oumuamua and why it was defying conventional explanation. And yeah, you nailed it in a nutshell there. It's like, well, yeah, it was either really long and slender or spherical, but yeah, longer than it was wide, very flattened by most accounts. And they didn't see any tail developing from it when it came around the sun. Upon first detection, it was just a bright object, no indication of gas coming off of it. And it was, it had a rather high speed, and it picked up an additional boost of speed as it was leaving our solar system. And again, they checked it, and they said, well, we can't prove there's any outgassing. It might be a little far for us to know for sure, but if that's what caused it to accelerate, then we would have noticed before when it made its closest pass to the sun. And they're like, and we can't factor in gravitational influence there, because the way it accelerated, it diverge from a trajectory dictated by the planets in their orbits at the time. So everybody started jumping on this with, well, okay, what could explain how it accelerated at the end? That is, not a comet, basically. What else could they be? And one after another, they all seem pretty far fetched, and so he said, well, just let's put the evidence to this possibility that it's an artificial object and that it picked up a boost because it was hit by solar pressure, and that would also explain why it was bright and weirdly shaped, and why it didn't start tumbling erratically after it did start accelerating, all the stuff you'd expect to see from a natural object. And to date, there's only one explanation that for a natural object that actually, made sense and could, and many have argued that this explains everything and so forth, and I've heard the back and forth about this theory too, and it's like at the very least, this explanation does kind of stand toe to toe with the alien probe idea. It's that it was a nitrogen iceberg. That these are objects that do exist, and they are what happen when stuff in the outer solar system collides and creates all kinds of objects that get hurled out. And yeah, well, the debate is ongoing about that. It's like that would also account for what we saw. It wouldn't have been obvious that it was outgassing. It could have picked up acceleration by nitrogen just getting melting there and or sublimating and blowing off. And it wouldn't have been obvious to us with our instruments that was what was happening. So yeah, it's like it's a possibility, but
there's another
it's possibility. Like one way or another. Yeah.
So this is where there's a conflict in my interest, because we're on Garden Views now, and Garden Views wants to stick to just the facts, and so there's two coexistent, that agreed upon, and that doesn't mean that there aren't other explanations. Just we don't know what they are yet. Now, Garden of Doom, my sister's show, my actual baby, we absolutely want it to be space junk or an alien probe. I mean that's what Garden of Doom wants, and of course since that's my baby, that's what I want, but I have to accept that it could be a nitrogen asteroid as well, and that's and that is fine, and that's not really the purpose of our show. But for those of you who, I think it's around episode, I don't know, it's probably in the 20s where I did it. But if you want to listen to Avi Loeb himself, I'm sure he's been on lots of podcasts, probably the Astronomy Cast. He's certainly been on Earth Ancients with Cliff Dunning, who, by the way, was my guest, episode 50, cheap plug, on Garden of Doom. But he's been on Cliff's show at least twice, and once directly because of this book. So check that out. It's probably around the same time that the Cliff was on my show. It was probably around episode 50, so probably about a year and a half ago. So if you want to do a search for that, but Matt is here to also talk about lots of things. And when he told me all things he's expert in, some of them are probably more for Garden Doom or maybe a different episode of Garden Views. But I still want to figure out what they are and maybe tease the audience. If after this Matt, doesn't hate me, doesn't hate the whole experience, and wants to come back again, maybe we'll get him back and talk about those things. But one of the things was cosmology. So, what is cosmology?
Well, that is basically the study of the universe as a whole, particularly its origins. How did it all begin? Where do we all come from? How did things get from there to here? And how's it going to end? Or is it going to end? So it is where astronomy and astrophysics get really philosophical and existential. And it's of course it's grounded in science. Wasn't always the case, but it's like the term cosmology has meant different things over time. Because the root word is just it comes down to existence and so forth. So that is a field that religion has continues to play on, and philosophy and metaphysics and so forth. But scientifically, cosmology is the application of scientific method to all the big questions, and it's very fascinating too. Because the theories that get tossed around in there, we're talking everything from the Big Bang, dark matter, dark energy, how galaxies evolve, extrasolar planets. and all of it has, yeah.
Yeah,
Any work, any discovery in these areas has such deep implications, right? Yeah.
it's endless. The articles that I see on various sites, and some of them repeat the same articles over and over again in different forms of sensationalism. But that our reality may be a lab experiment or a science experiment. Basically, we're in the matrix. That interdimensions, which of course quantum physics, somehow theorizes is possible, maybe even likely, depending on who you talk to. I don't pretend to really understand that stuff. People famously know I don't even like British science fiction, and I'm really not the biggest fan of Spider-Man Into the Multiverse and the latest Doctor Strange because I just am not interested in other dimensions.
Yeah.
It's too easy. Um, that the Big Bang Theory was actually one in a series of infinite Big Bang theories going backwards. That our universe is not the first universe. So when you say everything has happened before, in fact, it has, because in infinity, yes, everything has happened before, and will happen again. Um, Going back to what they kept saying in Battlestar Galactica, and pretty much religions to Shirley MacLaine and reincarnation, and you name it. At some point, science and religion, they seem to be getting closer and closer. Especially when I saw something where scientists could detect electronic discharges from the brain after a body died. I mean, and that's energy. And how is that so different from a soul, if at all? I don't know. It depends what's in that energy, right? But we can't read it yet. Um, so anyway, so relativity. I assume when you said relativity, you meant the theory of relativity, Einstein. Was I correct about that, or is there more to it?
No, yeah, that is Einstein, and when it comes to cosmology, right? Yeah, that is one of two fields that can explain how things work on on the total scale, right? And it describes how things work on the larger scale, gravity. Whereas, yeah, quantum mechanics describe how everything works on the tiniest of scales. And yeah, even in quantum theory, there are people who are drawing a connection between that and consciousness and thinking maybe they're the same. And well, yeah,
Right.
it's like if you don't want to go down a multiverse rabbit hole, yeah, it's probably good to hang back from quantum mechanics because that does get weird.
Yeah, it'll hurt. It'll hurt my brain, so maybe it'll hurt someone else's brain too. The theory of relativity. Everybody's heard it, at least in the last 75 years, thereabouts, probably longer. Um, all I really understand is that basically that if you move faster than the speed of light, time sort of starts to bend and eventually can go backwards. I'm sure that there's much more to it than that.
Mm-hmm. Well, yeah, that's known as time dilation, and it states that that no object can ever go faster than the speed of light, and I'll tell you why in a second there. But yeah, time dilation is that when you accelerate to the point where you're getting closer and closer to the speed of light, you're going to notice time is slowing down by greater and greater measures, right? And so, yeah, objects that are doing that, their inertial mass, as it's called, increases, right? That's what Einstein was explaining with E equals mc squared, right? As you accelerate towards the speed of light, time slows, but your mass increases as a way of sort of maintaining balance, which means that more energy is going to be needed to push you further along and go faster. And so this is why no objects can reach or exceed the speed of light, because their mass will become infinite. And the energy that would be required to get them to that point would be infinite. So it's like, well, if you can find a loophole in that, and there are people actually who are working on that very thing right now, great. But otherwise, yeah, we live in a relativistic universe, and you got to accept that yeah, nothing can beat the light, in a foot race.
So Superman 1 lied to us.
Yeah.
And
yeah,
Star Wars. Oh yeah, he went back
yeah.
to reverse it to save Lois from the nuclear bomb that Lex Luthor dropped. Not before Racing Otisville. My favorite part of that movie, by the way.
And
yeah. So
reversing Earth's rotation doesn't reverse time either. That was It was kind of fun for just superhero purposes, but oh yeah, they really lied to us there,
So anything with the Flash doing it also nonsense. All right. And Star Wars
pretty
with
much.
hyperspace, no such thing.
Well, yeah, that this has been the ongoing thing with science fiction, right? It's like the universe just doesn't seem fun unless you can really just go through it, but you have to exceed the speed of light in order to get anywhere in a short amount of time. Um, and there is actually a theory for going faster than the speed of light. It's called the Alcubierre warp drive, or the Alcubierre metric, which describes it there. And I had the opportunity to talk to Dr. Harold Sonny White, and he's the guy who did all the warp research for NASA. And he retired from NASA in 2019, and he's now in part of a nonprofit that's continuing this research called Limitless Space. And yeah, so we had a chat, and basically he described in 8-year-old terms how that worked, because I had basically understood how it worked, but not in an intelligent fashion there. But yeah, it's the idea there is that, well, you can't exceed the speed of light, but what if you could make it that space time itself around you, that it was contracting in front of you and expanding behind you using actual known principles of physics? Then you could basically, the ship itself would not be moving, but rather just the local area of space time there. This bubble would be shooting you along, and then yeah, you are basically going faster than the speed of light, but only according to somebody who's watching from the outside. You who are in the bubble, it's like you're moving along, but your ship's speedometer says zero,
So
and
you are
your clock.
surfing on, you're basically riding something else moving faster than the speed of light,
Yeah,
the bending of
yeah,
actually something physical.
yeah. Yeah, because space time, and then this also goes back to Einstein. There, it's like space time does bend, right? It has a curvature which is caused by gravity, and objects with mass cause the space time curvature to sort of bend around it, and one of the ways he sort of stumbled onto relativity was that it's like, well, there's really no difference between acceleration and gravity. If you're on a ship and it suddenly starts accelerating, and you're standing there on the deck with your head facing to the top of it, you feel like you're experiencing gravity, right? You're being pushed down, and if it's going 9.8 meters per second squared, that's the same speed at which gravity happens. You feel like you're standing on Earth, and he used the example of an elevator, right? If you cut the cord on an elevator, it starts to do free fall. The person inside feels weightless. And once it hits the ground, however, they go. They get hit with a force of gravity that's much more intense, and that will probably crush them completely.
So is this in
So
essence? I'm water skiing. There's a wave that somehow is going much faster than the boat I'm going on, and I catch that wave with the water skis, and I somehow pass the boat.
yeah, in fact, that's a perfectly good analogy there, right? It's like if the properties of the water can be toyed with, exploited, to create that wave, then yeah, you would be riding atop that, and you wouldn't have to move at all yourself, right? You wouldn't have to exert yourself to start moving. So yeah, you could go way faster than you otherwise would be. And yeah, the one drawback about the whole this whole idea is you'd have to generate a tremendous amount of energy and negative mass. That's one of the principles there, and it's theoretically possible. It's just we don't really know how to do that yet. So that's how that's coming along there, right? We're working incrementally towards the point where we can generate negative mass on such a scale that it would be enough to surround a spaceship and make it just go right.
Well, we'd also have to
It's
figure out where we want to go.
oh yeah,
and I guess
Yeah.
when we want to get there, right? I mean, yeah, both.
Yeah.
You need some sort of a GPS system, which
Hmm.
I mean, unless you really want to go places that no man has gone before, or at least not
Hmm.
in this Big Bang reality. Um,
Yeah.
okay, so let's go on to the next thing: exoplanets. So exoplanets, as
Hmm.
I understand them, are planets that are outside of this solar system. Um, and then, of course, that's where the subcategory of Goldilocks exoplanets are planets in other solar systems where we believe our understanding of what the parameters of where life can survive are within zones that there's enough gravity but not too much, as some form of atmosphere, that water can be produced, the temperature is not too terribly extreme, I suppose, though I guess that gets the more life we discover on earth in extreme temperatures, I suppose that maybe changes. I'm not sure, but why should I speculate or say what I know from my level when I have an expert here? So tell us a little bit about exoplanets.
It's funny. I was just talking to a colleague about them. But yeah, you're absolutely right. The full term is extrasolar planet, which refers to any planet that is beyond our solar system. And in fact, we have only been detecting them since 1992, which I found very interesting. But yeah, it's like back in prior to at that point, scientists had um, no definitive confirmed evidence that planets even exist beyond ours. There were plenty of hints, right? They noticed that stars wobble, and that implied that their gravitational force was working on them and shaking them back and forth, and that became one of the two best ways of determining that there are planets there, measuring how the star moves. But yeah, as of 1992 and after, we were finally at the point where our instruments were sophisticated enough that we could apply this and other methods to indirectly detect exoplanets. And yeah, we're now getting to the point where the instruments are getting sophisticated enough that we're going to be able to directly detect and study them. And what that's going to lead to is yeah, we're going to be at a point there where we're no longer focused on discovery but characterization, and we're actually going to be able to characterize these planets for sure. Yeah. So to date, the best we could do is we could say that, well, okay, so we watch this star, and every so often its light dips a little, and this is called the transit method, right? It's like those dips, if they're consistent, if they're every few days or few years or however long, sometimes even hours, then that confirms that there is a planet orbiting that star with an orbital period of whatever. So it takes weeks to a year to complete a full orbit, and based on how low the light dips, right? It's usually just a tiny amount, but that's enough to get a good reading on how large the planet is. And you combine that with the orbital period, it's like, well, okay, so at that size, and the way that orbital period, we can we can safely say that it's this far from the star. And given that that star is particularly bright and powerful, that's going to be a hellish place. Otherwise, it's like, well, yeah, this distance is right where it would need to be to get enough energy so that water can be liquid on its surface. And the other technique I mentioned, where you watch the star for signs of wobble, yeah, that's called the radial velocity method, or Doppler spectroscopy. And yeah, that there, it's like you're able to measure the gravitational influence that the planets have on this star, and that works really well for.
So, all right, we got cut off there, but we reconnected, and I believe at the time Matt got cut off, he was sort of talking about the wobble and how we direct or detect exoplanets.
Mm-hmm. Yeah. Sorry about that, folks. Yeah. So this method is known as the radial velocity method, right? and it's very good for determining the mass of the planets that orbit around a star, especially dimmer stars like the red dwarfs. They're not really bright enough to do the transit method with. So, but combined with the transit method, it's like um, you can determine not only if the presence of planets and how big they are, but also how massive they are. And from that's currently what our main means of determining if a planet is potentially habitable. That's what it comes down to. You're indirectly determining how big this planet is, where it orbits, if it's in the Goldilocks zone, and based on its size and next to its mass, whether or not it's a rocky planet. So that's how astronomers so far have been able to say we think this place is potentially habitable because it's close in size and mass to Earth, and it's far enough away from the sun that it's going to be getting all the heat and radiation it needs. But the problem with that is that you can't say for certain whether or not the planet has an atmosphere, whether or not it's got a global magnetic field. You can't tell what the composition of its atmosphere is. So that's something we're looking forward to, right? With direct imaging, it's like you not only need powerful telescopes for that, you need a lot of the advanced tools that we've only had started having recently, and that includes an instrument called a coronagraph, which is capable of blocking light from images that are taken by telescopes. So it's like, well, if you apply that right where the sun, where its bright disk is, and block that out, then suddenly you can see light coming from around it much better. And then, well, yeah, if you can see small points of light that are moving around it, you know that there are planets there. And if you can then scan that light coming from those planets, right? Because it's being reflected off of them. If you can run that through a spectrometer, which breaks down light into its different colors, its different wavelengths, you can then pick up chemical signatures because different chemicals absorb and radiate light at different frequencies, and then so it's like okay, from that collected information, the spectra, we know that there is oxygen and nitrogen and carbon dioxide in that atmosphere, and then from that, it's like, well, that's what we know. Life, as we know it, needs to survive, so that's a great sign. And what else? We're detecting things like methane, which is an organic molecule and is associated with life. It's like, yep, we see that there too. Great. That means that, yeah, this planet went from potentially habitable to habitable. Of course, the next step beyond that is it inhabited? Well, we'd have to get closer for that,
Right.
or we'd have to spot telltale signs of that there, like yeah, can we detect
Lights,
industrial pollutants?
lights, signals,
Yeah.
pollution, satellites. Yeah.
Mm-hmm. Yeah, and it's like we're getting closer to that point, and it may come sooner than we think, or not. But yeah,
What a,
it's
what a
like if
what a time to be alive. I mean, I wish I was a little bit younger.
mm-hmm.
So there are so many things I want to ask you, but I think that they're better for Garden of Doom. So I'm biting my tongue so many times on things that are serious, but are tied into other frivolous things. But I'm going to stop because this is Garden of Views, and I'm going to behave. That's behaving too. It's just a different kind of behaving. So this is a great segue into what's actually planned in terms of crewed missions, but it can be unmanned missions too, and by whom really? I mean, because there's governmental actors, but there's also non-governmental actors, and I imagine there will or are some private-public partnerships as well, if not now coming. So, what can you tell us about crewed missions or other large missions that are important going to the moon or Mars or wherever else that you think is on the near term horizon, and by that I'd say within the next, decade.
Yeah. Well, yeah. Within the next decade, it is going to be the Moon to Mars plan, right? And that's if looking at NASA. who's still very much the leader in space, right? Yeah, this is a plan they've been working on since about the mid 2000s, and yeah, it was back then. It was all about we need to build some heavy launch rockets again. We plan to retire the space shuttle within the next few years, so we need something that is not just send stuff to low Earth orbit, but beyond it. Because yeah, nothing had been beyond nothing human rated had been beyond low Earth orbit since 1972 in the Apollo era.
Right.
And well, we're still at that point, but we're getting very close to breaking it. So yeah, what's going to happen first is Artemis, and that's its current name, but it's really just the successor to right 2005, 2010, 2016 when sort of the mission architecture was all being put in place and shared. And so Artemis is basically phase 1 and 2 of NASA's long-term plan. Let's build the new rockets, the new spacecraft. Let's keep doing research on the ISS into microgravity and radiation because we really need to know about how that's going to affect us. And then let's send missions to the moon again. And the idea was that between 2020 I think was the 2016 I think actually was the original go date, but it got pushed back. Yeah, it's like we're going to start in the early 2020s. We're going to start sending rockets up, test how they do, send a crew up, send them on a journey around the moon, and then there was at one time they were going to tow an asteroid to lunar orbit, and a mission was going to go rendezvous with that to test out all their capabilities and give the crew some time in space. But that got scrapped in 2016, and then it was no, let's send that mission to the lunar surface. Big triumphant return, right? A big sort of payoff in terms of PR. And it's like, well, yeah, that's a good idea too. So NASA made that adjustment, but then a key part of phase 2, which then would work on to phase 3, was they said we want to build the lunar gateway. And that's the orbiting space station that's going to be in orbit of the moon, and we want that there. And then if we were going to do a return to the lunar surface, well, great, we'll put a reusable lunar lander there because this station is going to be the thing that spacecraft coming from Earth dock with, and so you got a lunar lander basically can pop up and down, and we can do missions that are weeks long, not just a couple days. And and this fit in with the idea that we also want to develop infrastructure on the surface, so possible refueling depots or whatever that's been recommended for a long time, and then we want to put a spaceship on that lunar gateway, which is going to, once you dock the Orion spacecraft with the station, you then transfer it onto the front end of this spacecraft, and it takes you to Mars. And so, phase 3 there was that, we're going to use that spaceship first to send another space station, a modular thing in orbit around Mars. And it's going to have its own reusable lander. And so when we start sending astronauts, which would start in 2033, right?
Mm-hmm.
That first mission, the crew would go. They would rendezvous with the Mars base camp station on the other side, and then use a reusable lander to, go travel up and down and do a couple weeks on the surface and then come home. So all that was, this has been the long-term plan, and it's long, it's expensive, but the idea was that, for one thing, we want to go back to the moon, but we want to stay this time. We want to establish all the infrastructure to stay. We're not doing another footprints and flags kind of mission like we did with the Apollo era, because it's like nobody would ever doubt the accomplishments of the Apollo era, but it's like that was all about getting there first, right? Now we want to get there and keep going back there. Yeah.
Okay.
Yeah.
So I have I mean, this sounds like, aside from patience and some technology, there's a lot of logistics involved. I presume that they have, they have got, pod type of technology that can be habitations, and most people have seen sort of the either the science fiction shows or the projections on, nonfiction television where they have sort of the enclosures. I guess so. You take like the International Space Station model and you or Lego and you sort of build them together. But
Hmm.
I mean, obviously, you need to have other things there like air. You need to have working. Um, you need to have food, which I mean, I'm sure you can supply with some things, and water. And I guess that requires you put tons and tons of bottled water there, or that they can find or create water um, on the surface of the moon and or Mars, or you have constant resupplies, which would be, I mean, I guess would be really, really heavy and really, really expensive. So, are there any? How do they plan to address, one, the actual physical structures, which is probably the easiest answer, and then the logistics of the necessities to live and operate and do something functional up there, aside from just being there.
Yeah. Yeah, good question there. And there is a wealth of work that is being done actually to address both. So to talk about structures, yeah, and this is a good way to bring in what other space agencies are doing too. So NASA is of course partnered with the European Space Agency, with the Japanese JAXA, and Canadian Space Agency, and others. All of its partners aboard the ISS, right? With the exception of Russia now.
Right.
Russia's been pulling out. There's cooperation's on hold there. But yeah, they've been working for years about how do we build structures on the surface of another planet that would allow for long-term, long-duration stays. Because yeah, they've got module type things that, or the spacecraft themselves, like the lunar lander and had been proposed, and also the Mars one. It's like these are large enough to accommodate crew and have supplies that could keep them alive and well for weeks. But we want them to have like research stations and the actual habitats that future crews can just keep going to, and kind of like the ISS. And so yeah, both NASA and the ESA had some very interesting ideas, and the European Space Agency I think was definitely the more elaborate one, and it's they call theirs the International Moon Village. And the idea is, yeah, let's transport some semi-inflatable structures, set them down. We rig them all up with solar panels, and NASA was doing the work on. Well, yeah, we also want some lightweight nuclear reactors, and we want to harvest the local resources to build these places up and give them radiation shielding and such. So 3D printers is a very widely consulted technology there on that. And yeah, we want to harvest the local water ice to provide for our basic needs there. So this way, we're not dependent upon resupply from Earth so much.
And that's
And there's going to
drinkable.
be, yeah, and that's I mean, because of course that's the biggest expense there would be launching ship after ship carrying supplies. It's easy to do with the ISS, right? It a launch will take just a few hours to reach it, dock with it, unload it, and then they throw their garbage in there, and boom, off it goes. The launch process is still expensive, but it's gotten so much cheaper. But if you want to go beyond low Earth orbit, it's like, well, you you either need a rocket that you're throwing away after one use, or you need to refuel it in orbit. And well, that's we got ideas for that too, but we'd like to minimize that. So yeah, and the same is true of Mars, right? How do we turn the local ice and all the rich silica soil into building materials, drinking water, and we want to pair that with some garden beds and hydroponics and all that stuff to produce as much food as we can, and that's going to allow us to send people there to live for a a few months, yeah, certainly at the time, possibly up to a year or more on the moon, and yeah, whereas they're going to be dependent upon Earth for supplies to an extent, they'll be able to see to their own needs as much as possible locally. And there's a word I've been waiting to use. I just keep forgetting to use it. It's called In-Situ Resource Utilization,
Ooh.
or ISRU. Yeah, and that's a major buzzword with all these mission planners and designers, right? So
Well,
you get
before I
the
forget,
resources.
I'm going to need you
Yeah.
to DM me that word because that's going to be the title of the show.
Yeah. So yeah. So the idea being that you're using local resources as much as possible, and that actually has a lot to do with where you choose to land. So a lot of lunar exploration and Martian exploration right now is targeted at regions where we know there's water, because yeah, the last thing we want is for people on the surface to start going thirsty, because that's a quick way to die. Oh, and you mentioned oxygen, like air.
Mm-hmm.
Yeah, again, you gotta bring that with you for obvious reasons, but you can produce it on site too, and that's another thing. Water, local ice would be good for you. You chemically disassociate it. You can create oxygen gas. Plug that in with like also a tank of nitrogen, which I don't think they have the means to make that on the moon yet, but that's okay. You put the nitrogen on to fill the air, and then oxygen, you mix them about 70-30, and the crew can breathe happily, and also you don't have to worry about lighting up. In a pure oxygen environment, you would kill yourselves if you tried to light anything on fire.
Yes, that would be very bad.
Yeah. Yeah, so for the love of a God, make sure the nitrogen valve is open too. And meanwhile, all the hydrogen you've gotten out of the water and separated from, you can use that to make fuel.
All right, well,
Yes.
the cartoon part of my brain right now is wishing we had the Green Lantern to go find one of those nitrogen comets and tow it over so you have a ready supply of nitrogen.
Yeah. Well, yeah, it's like if you the farther out you get into space too, that's something that a lot of the long term planning is. It's like, well, it's great because a lot of these gases that are really really useful. Yeah, the further out you go, the more you'll find, because it's frozen solid, and you can chip off a block of methane ice and melt it back in the habitat, and you got gases to cook with.
Right.
But again, don't light up.
Right. No.
Yeah.
Flame free zone.
Yeah.
This is a great segue, I think, into what are the laws and or treaties that exist. Now, I understand that there's these partnerships between the space agencies, but is there anything beyond that? For instance, I know that there was a treaty on the moon, but I think that the United States is not a party to it. I know that the last administration issued an executive order, which I'm not sure how enforceable that is, period, but it basically said that any private companies could, I guess through a license, through Space Force or whatever, could go up to any celestial body, including the moon, asteroids, and Mars, and they could harvest whatever, mineral or resource rights they would, but they couldn't claim the celestial body for their own. It was still, I guess, U.S. or I guess it was silent on that. Those Trump administration. So I'm guessing there was at least a U.S. right of first, U.S. company, U.S. right of first refusal. But aside from me guessing or rehashing things I read a year ago or 6 months ago, what actually is there that you've come across in your journalistic endeavors?
Yeah. Well, yeah, that's a good one, and it's becoming a very very contentious issue. And in fact, one of the groups I talk to pretty regularly, and I'm sort of a semi-affiliate with, is the Spaceport Foundation, and the Space Generation Advisory Council. They are the ones. They are the first nonprofit legal entity that's trying to iron all this stuff out, right? Trying to create an international framework for all this humans going out there. And there's also the Kepler Space Institute, of which I'm part, that is trying to come up with a legal certification process for space medicine. So
Wow.
there's a lot of work going into addressing all the things that we know we're going to have to deal with. But your question was existing treaties, and of them, the most important, the most far-reaching, is the Outer Space Treaty, and that was passed in 1967, and that was originally the Soviets, U.S., and the UK were signing it, but today, uh, yeah, well over 100 nations have signed on to it and recognize it. And the basics of it was that, yeah, the exploration of space is to be done for the benefit of all countries, all mankind. You can't claim things in space. Um, the Moon Treaty was meant to be an addendum, and it was it was it passed through the UN in 1979. But unfortunately, yeah, it was not signed by the United States or any other power that would have the means to like enforce it and give it and make it meaningful. Um, and there's slew dozens of other treaties that were agreed to that cover everything from rescuing astronauts and liability for damage to other people's spacecraft or their equipment. Yeah, and all of these were specifically designed with let's demilitarize space before it becomes militarized.
Hmm.
Yeah, but in terms of the moon, yeah, the Trump administration complicated things somewhat. They said that um, there'd already been measures passed about commercial activities in space, which was signed by the Obama administration. But yeah, the Trump administration took the really bold move of saying, asteroid mining and mining on the moon is now legal, and companies can keep their resources. Beyond that, I have no idea what legal precedents it actually established, because you're absolutely right. That is a sticky legal question. It's like, who gets to decide who works where and whatever. And they did refer back to the Outer Space Treaty, right? So it's like,
Hmm.
wherever a national entity is exploring, they're responsible for anybody there.
Yes.
Um,
And
yeah.
my in real life, I'm a lawyer. I'm not a constitutional lawyer, but I
Mm-hmm.
retain enough of it to remember that treaties need to be ratified by, I believe it's the Senate, if not the House
Yeah.
and the Senate. But that wasn't done with this executive order, and the executive, the Article 2 executive, is the commander in chief of the military and runs foreign policy. Now, where
Yeah.
does well, this is not military, so it doesn't fall in that. And if you're running foreign policy, I mean, where does foreign policy end? Does it not? Does it end at our atmosphere, or does it go beyond? So I'm not even sure that there's a law on Earth that could satisfactorily address this. And there's probably other actual cases out there like this, but there's actually a federal case where somebody sued Satan, and a federal judge said dismissed the case, and looking for a reason to dismiss it, they said, well, the laws of earth and man do not apply to Satan, that is not an an earthbound creature, or something like that, which could be precedent in a case for somebody saying, you can't stop me, US, or you can't stop me, China, or you can't stop me, whomever. Well, US, I guess, would be precedent, but say, hey, your own court said you don't have authority, on things that are not earthbound. And, you want to talk about satellites or whatever, and go as far as 22,000 miles. I doubt it, but, I'm going, 22 million miles, or however far Mars is. And surely the laws of Earth don't apply that far, um, which I guess could apply to a government if one government thought it was so far and away beyond another one with its capabilities, including space military, which we have Space Force, but they're a pretty small branch, and I don't know that any
Hmm.
government feels that, and probably they're still in most of their assets are on Earth. So that brings us to private entities. Um,
Hmm.
and I'm sure most of those private entities, if you have that kind of money, that kind of Blofeld money, a Spectre or whatever, it's based on Earth-based technologies and customers, but for how long? So after that rather long dissertation, what is the role of the private sector and these other, before you were talking about the Kepler Institute and others, they're trying to forge
Hmm.
things going forward. So where do you see the role of institutes like Kepler and other not-for-profits or even governments trying to work on this with governments who possibly are not going to be good actors, including possibly our own? Um,
Hmm.
Meaning the U.S. and or the private sector, who certainly may have their own agendas at point. I mean, here is my little game that I play. And it's not much of a game, but that the space becomes the British East India Company, where the company that plays ball with the government. So I guess it's going to be Boeing because they have a lot of U.S. and world Earth based business. But let's just say the country of Jeffzikistan. That's my placeholder. We're like Wakanda. We've got all technology in the world, and we can do this. And we want to be a bad player. And I send up 50 Wakanda, not Wakanda, Jeffzikistani Space Force commandos to Mars and say Mars now belongs to Jeffzikistan. Who's going to stop me? And while I say this, I have two other shuttles going up with 75 more Jeffzikistan space commandos. So who is going to stop me? Is there any mechanism for that?
Uh, well, currently, the United Nations Office of Outer Space Affairs, right? They are the legal entity, and of course, yeah, it's member nations there, signatories. That they're the mechanism to do that. But in terms of what they can do, if like say, we were talking about China, sending armed taikonauts, as they call them, sending them to the moon. It's like, well, yeah, this is the reason why uh, groups like Space Force are being created, because people predict that there could be a problem like that at some point, and there's going to need to be some means of response. Um, for the most part, it's well, if you're trying to do something naughty out in outer space, well, we're going to try to punish you down here on Earth, and yeah, the way to do that is through concerted actions, sanctions, and telling the leaders there, don't do this, it's stupid, and you're a signatory to the Outer Space Treaty, so you're not allowed to do this. Basically, just good old fashioned diplomatic pressure and trade sanction pressure, and yeah. But in terms of what could be done in outer space, this could very well result in the militarization of space. This fear and this inability to stick to the framework we have in place down here in the United States. Well, NASA wrote up the Artemis Accords, and as I was saying to the Space Court Foundation a while back when we were talking, I said that I got the distinct impression that NASA produced this idea, this document, which is still very, really, really needs to get legally sorted. That they created that as a way of doing sort of an end run around the what the Trump administration had signed into law. It's like, we want all things on the moon to proceed in accordance with the Outer Space Treaty. So if anybody is going to be mining and extracting resources, well, okay, fine, but if you're doing it in this area where NASA is doing research, or any of its partners are doing research and exploration, you're answerable to us, and you don't own the land that you're on, but you can claim the resources you pull out. And yeah, so legally speaking, this there is a lot to unpack and sort and really get through here, because yeah, there's no solid legal framework for anything in outer space right now.
All
The
right.
Outer Space Treaty is a very good, start. It's a good touchstone, and that's why space agencies keep going back to it. And the ISS is a good example too. But yeah, it has to be something that the players in space can actually agree on and hold each other to whatever means they have available to them. Yeah.
Do you know of any group or government, or maybe even the people you're associated with, the astronomy cast folks, Avi Loeb,
Mm-hmm.
anyone who's working on trying to build some sort of framework? I mean, famously, there are certain, think tanks who, write up propositions or proposals, recommendations to Supreme Court justices, for governments, for, sometimes for one party or another. And, sometimes they get adopted in full or in part. In my field, the American Bar Association writes model rules and model statutes, and the states oftentimes adopt them word for word, or 90% plus. So, is there anything like that out there that's trying to do that beyond what you just talked about with NASA? Trying to draft the articles, the Artemis articles or Articles Accord.
Mm-hmm. Well, yeah. Let's see. So you have the Spaceport Foundation. They're one group. The Space Generation Advisory Council. They work through the UN, so they're the ones doing that. It's all about basically getting the nations of the world to get involved in hammering out kind of legal requirements and just raising their awareness. There are a number of legal institutes that are contributing to this, and McGill University, actually in Canada here, has they have a space law library, and they're not the only ones. There are others too, and yeah, most of this is happening through the UN right now, and it's their Office on Outer Space Affairs, also their program on space applications, and yeah, that and a number of other nonprofits they've all emerged in recent years for this exact reason. They understand that this is something we got to deal with going forward, and not the least of which is because of commercial space. In fact, that's precisely why the Moon Treaty was drafted. It was like the Outer Space Treaty says that no nation can claim sovereignty over stuff in space, but we don't have anything that says in unmistakable terms corporations and individual private citizens can't.
Right.
And
And it seems that SpaceX is basically lapping NASA several times over, and Bezos is probably isn't too far behind.
Well, that is the perception, but it's like people need to keep in mind. It's like, well, SpaceX, NASA is their bread and butter. If it weren't for NASA, they would be entirely beholden to the private sector for launching satellites for them. And it's like, well, they'd still be making a darn good living, but yeah, they would not be where they are right now. And of course, whereas NASA has stalled rather publicly with the development of its rockets, right? The SLS rocket has gone over time, over cost repeatedly. That nevertheless, they're still sending missions to the outer solar system, exploring all the planets there, and contemplating the next moves that they're going to make. Exoplanet research is a big one. Space telescopes is another. The New Horizons craft that buzz by Pluto and has actually been studying Kuiper Belt objects, right? And Cassini studying Saturn and its moons. Like, if you consider the totality of it, NASA is well ahead. But yeah, SpaceX and a handful of other commercial space entities, they are kind of embarrassing it, closer to home. And yeah, in fact, that in terms of Artemis, one of the consequences of another Trump administration decision, which was we want to move the timetable up 4 years sooner, right? That was 2019. Pence declared that we're going to land on the moon by 2024, no exceptions and no explanations. It's like, yeah, that caused all kinds of chaos and upset for NASA, and they continued to put on a brave face. Oh yeah, yeah, we're gonna do it. But my first impression on that was, it's like they're never going to be able to get the gateway up there in time, so they're going to have to do a direct landing from whatever spacecraft they use to get there, and that's going to be like an Apollo mission. So what do you do? What's the plan beyond that? There, you're basically reducing this to a footprints and flags thing again.
Right.
But NASA worked around it. They're like, oh no, we're still going to build the gateway. It's just we're going to send that up. The elements of, but early in SpaceX is going to launch it. It's like, okay, we still need a lunar lander rated craft to get the crew there, and SpaceX got the contract to do that. And meanwhile, SpaceX is also getting the cargo and crew, the commercial cargo and crew program, and that which worked out pretty spectacularly for them. Astronauts are now launching to the ISS from NASA facilities. But yeah, it's like SpaceX's success has been largely due to this idea that we just outsource it, just go to the private sector. Whatever plans you've got have been changed by the latest administration, and yeah, they've fallen back on very heavily on SpaceX.
So how
So
concerned are you about, Pinkerton's private space marine force, going out, and let's not say SpaceX. Let's turn Jeff Zikistan into a private corporation, not a country, and say Jeff Zikistan wants to hire the Pinkerton Space Security Force, and is anyone actually really concerned about that, or is that just me having an overactive imagination?
no, I'd say everybody is concerned about that.
Okay.
Or every thinking person is concerned about this, because yeah, in fact, the allegory you used about the East India Company, yeah, I've heard that one a few times now. It's like, we do not want a repeat of the age of imperialism, the Wild Wild West, or any of that. We don't want robber barons making claims to astronomical bodies and just pillaging them for wealth. And we especially don't want indentured workers going out there, which was actually an idea that Musk had floated, and I think he had to walk it back because someone made that comparison, right?
Oh, I'm sure.
So
I think I mentioned it
yeah,
on one of the prior shows, which I don't expect that you would have necessarily heard or not. But, UAE has a space program. And, I don't know about UAE, but some of those countries are well known for having their, low paid workers from countries like Bangladesh and Sri Lanka and places like that. And you could easily extrapolate that into, you could have them be sort of the indentured workers for space. And I don't want to throw UAE or Qatar or Bahrain or anyone like that under the bus, or Kuwait.
mm-hmm.
I don't even know if that's accurate anymore. Um, but it's definitely part of it. And if Musk can say it out loud, that probably means 40 other people with resources, or your presidents have thought it as well. I mean, you always use the disenfranchised, the people with the least to lose, always take the highest risks.
Yeah, and yeah, that's exactly right. The In fact, if I recall what Musk said, he said that yeah, I want to start colonizing Mars. We're going to send starships regularly up there, like 100 ships there doing regular launches every 2 years, and just in the course of like a Twitter conversation, which is normally how these things go with him, right? He said that well, yes, it's going to be expensive for people to get there, but if you can't afford it, you can take out a loan with our company and work it off. And then the response to that was, "Oh, you mean like indentured servitude? Oh, okay. And
Yeah,
what's the interest on those loans?" And yeah,
sharecroppers, right?
tell us. Yeah, yeah, exactly. It's like they're going to be designed in such a way to keep you in debt for life. And
Right.
yeah, so
No,
yeah,
no
there's a great
multimillionaires
concern.
work on oil rigs or become ice truckers.
Yeah, yeah. And yeah, so there is a considerable concern there, and more to the point, one thing that I draw some reassurance from is the fact that it's like, well, SpaceX is not going to be able to do any of this on its own, even though their progress has been considerable, right? And NASA certainly is not going to be able to do all this alone. It needs its commercial partners. It needs those commercial partners to have a legal framework to restrain them from doing anything, super villainy. Um, and of course, the international partnerships; those need to continue. And all these things are in everybody's best interest because nobody really is going to benefit from a free for all kind of situation. Um, and yeah, the billionaire class are known for thinking that they can do whatever the hell they want because they usually can. But yeah,
I
but
also think
space
that
is hard.
in the founding principles of whatever agreements are drafted, whether or not we acknowledge that there's sentient life in space or not, or on near celestial bodies, I think that they should presume that there is. Um,
Yeah.
because we don't know what life will necessarily be, and I'm not sure that we know where sentience can necessarily be found. But I think if nothing else, just to have those first principles and not repeat beyond indentured servitude and things like that. That there's other things like colonialism and slavery and inadvertent genocides that
Yeah.
maybe can be mitigated. I say maybe because there's so much that we don't know and can't control, but at least you can try. Um, in that, and so we have to pretend that there are in fact little green men, and the little green men have kids that they love and stuff like that.
Yeah. Well, yeah. It is a safe assumption. It's a good one, and yeah, it's even been I remember a research paper that was floated that said we need to jump on the idea right now that this false notion that the resources of space are limitless and the room within which to move, because if we like making comparisons to the past to popularize these ideas. The idea of new frontier exploration and so much to learn and grow and how this country was founded. It's like if we're going to do that, in a positive sense, we have to look at the flip side of that, right? All the negative things that happened. One of the things of the colonial imperial era was this perception that limitless space into which we can spread such abundant resources, and yeah, a lot of people even at the time they were looking around there thinking, nope, it's quite there's a lot of resource, a lot of trees, a lot of land right now, but like not only are people being murdered to clear that land, not only are people being enslaved to work it, but the resources themselves are finite. It's just they only seem infinite because right now we haven't our current numbers aren't going to make a huge dent, but they will eventually. Yeah, so our future in space, there's a lot of people who say humanity's future is in space. I would say yes, that is true. That's probably the only way we're going to survive as a species, and I'm talking about climate change and overpopulation, in addition to an asteroid strike. Yeah, in fact, I think an asteroid strike is probably one of the lesser arguments for why we need to get out into space more. Say, yeah, that's always a possibility, but that seems to me a much less likely or less that threat is addressable, whereas just our civilization collapsing due to sheer numbers, short-sightedness, inaction on climate change and so forth, that's a way more likely scenario. We need to get out there, do the research, and utilize the resources to save our planet. But yeah, there's every possibility that our future could be just like our past, and that we go about that the wrong way.
Well, so I think this is probably a fitting place to tie this one up in a bow. But there's so much more to talk about, and I hope that you will consider coming back again, both on Garden of Doom and Garden Views, Garden of Doom, we can maybe have a little bit more fun with, comparing what science fiction shows have, or movies have gotten it the most right, and what we should worry about from there, and other topics as well. But and maybe some of the more fantastical things that science has detected. Not that talking about relativity and space surfing, basically, or water skiing to beat the speed of
Hmm.
light isn't fantastical in and of itself. But as things emerge that are policy driven, reality driven, science driven, and legal driven, I'd love to call upon you as a future resource and maybe a
Totally.
reference for other people who are willing to talk about this. It's good to know that there are people and organizations and not for profits that are thinking about this and actively working on it. I was sort of afraid I was the only one doing it
Oh no.
actively. Well, that's good. I mean, it really shouldn't be.
Yeah.
It shouldn't be some lawyer who's been podcasting for 2 years being the only one to actually be pursuing this in some sort of semi methodical way, because I also try to make it somewhat entertaining anyway. um, but yeah, so is there
Hmm.
anything else that you want to tell us that we haven't covered and or promote where people can find you, support you, or any of the work that you do or are involved with, any of your journalistic works, if you have any fiction, et cetera, et cetera?
Yeah. Yes to all of that. Well, for starters, yeah. So I would like to mention how, yeah, the podcast series. I believe I already mentioned it earlier, but that will be coming up very soon on ITSP magazine. They're rather large and community of podcasters who have their channels to this one place, and it stands for the intersection of technology and society. And yeah, it's called Stories from Space, and it will be their first dedicated space podcast.
Awesome.
So yeah, so there's that. I invite people to come by Universe Today in Interesting Engineering. Just look for Matt Williams. I'm usually there. And yeah, well, actually, I have a link to fiction that I've written, which I wrote a series of books between they were published between 2017 and 2020. Unfortunately, the publisher is not going to be around that much longer. They didn't survive the pandemic, so
Oh,
yeah, they're curtailing. But I do plan to keep these titles available however I can, because yeah, I'm working on other ones. But yeah, that basically the books, much like the writing I do, it's about where well what you deal with on your two channels. I'm always trying to find the middle lane there, that where the two things just inextricably merge, right? Like, yes, this is cool. How is this? How can we do this? How is that going to happen? And, or yeah, on the other hand, it's like, oh, this is dark and scary. Let's talk about that.
that
How's that
works
going
too.
to play out?
Yeah.
Yeah, yeah. So yeah, that's about all I can offer. That is me beyond within and beyond what I do for my day job.
Okay. Well,
And
wonderful.
yeah, yeah. Oh, and yeah, this summer I will be teaching. Not this summer, sorry. This fall I'll be teaching a course through the Kepler Space Institute about this one will be specifically geared towards Mars and our the exploration thereof, our collective views of it and understanding of it, which have changed so much in the last in the course of recorded human history, and yeah, how we might live there someday. So that, I think, will be a good time for anyone who's interested in the idea of humans living off world, and what we actually know about the planets that are out there.
All right, folks. Well, you've heard it all. You've heard where you can reach him. You can, if you're in the area, or maybe it's an online course, you can look into that at the Kepler Institute. I will try to put the link. I'll try to remember to put it into the show notes, but it's https colon backslash backslash www.amazon.com backslash Matthew capital M uh, hyphen capital S hyphen Williams That should be enough to find it. The rest of it is all the technical backslash stuff that if I read it, it'll just sound like I'm reading a whole lot of numbers and probably I'll get them wrong because my nearsighted vision is going quickly. Um, but yeah, and we hope to have Matt on again. He seemed to give his assent verbally, and I can see him on Skype visibly
Yep.
here as well. So that's going to be really cool. So, folks, please take heart on that, and we're going to continue our exploration into the emerging law space with as many people as we can get to talk to us about it until we think that we've gone about as far as we can. And hopefully, folks like Matt and the Kepler Institute and others will keep giving us more material that we can keep going with it. Um, or we'll stumble onto something else at that point. But I imagine that we'll have plenty of material for the future. So, please rate, review the show, share with your friends. Let them know that we exist and what we're doing here. And if you subscribe to Garden of Doom, you get Garden Views automatically. They're on the same feed. If you don't like Garden of Doom, just delete it. But that's the only way to get Garden Views. I want to thank our friends at the Hameen Media Group, at Wrestling Suit Network, and at the PWC Network, who all carry this show. So thanks to all those folks. And we will hopefully hear you next week.
I've been stuffed in your pocket for the last 100 days. When I don't get my bath, I take it out on the sleighs. So grease up your baby for the ball on the hill. I'll polish them rockets now and swallow those pills and say, oh. Space Lord, mother. There's a car in the